Okay, so let's begin some examples with finding area. So here we have a simple right angle triangle here, and we apply the formula area equal half base times height, and our base is, which implies that half, our base is what? Our base is 6 centimeters, and our height is 3 centimeters. So we multiply this times this is equal to 18 divided by 2. So it's going to be 9 centimeters square. This is where the square comes in. The square comes in when we're doing area. So the end of any area question, we're going to have centimeters squared. Why do we have centimeters squared? Because we have 2 centimeters multiplying each other. 6 centimeters, 3 centimeters, multiplying each other. Whenever we multiply something by itself, we always get squared. When we added it back when we were doing perimeter, there was no square, because when we add like terms, we don't get square. But when we multiply them, we get square. You multiply 6 centimeters, multiply by 3 centimeters, we get 9, divided by 2, we get 9 centimeters squared. Alright, because we're multiplying 2 centimeters. Good. Here we have a square, because I wrote it here. Square. We have 4 centimeters. Find the area. We know that a square has all its sides are equal. A square, all its sides are equal. So when we're doing the formula, length times width. Alright, that's going to be 4 centimeters multiplied by 4 centimeters, which is 16 centimeters square. Don't forget the square. Alright, that's pretty easy. Let's move on to some more challenging ones. So here we have a trapezium. Both sides are slant. We handle it the same way as we do if only one side was slant. What's the formula? Area is equal to half A plus B multiplied by H. You plug in half, what's A? 5. What's B? 7. What's H? 6. These are all centimeters, by the way. And the end result will be 12 times 6, what's that? 72. 72 divided by 2 equals 36 centimeters square. Alright, we can always leave off the units here, but at the end we must always remember to put back the units. If you don't put back the units, I don't know what you're doing, but it's not measurements. Okay, so try to remember the units. Units are very important. And as you can see, we're just following the formula. We're not employing any brain power as yet, but we will. Don't worry. Here we go. The first example where we employ some brain power. So this question, they ask us to find the area. Well, I didn't write it, but here we go. Find area. This is an irregular polygon. There was no formula to find the area of this irregular polygon. Never fear. We can do what is called dissection. So we dissect the polygon into regular polygons. Okay? So I had some dotted lines here. And this is to show you that we can cover up this right here and solve for this little piece. And then cover up this right here and solve for this big piece. And then we add them. Alright? We find the area of this little piece. Then we find the area of this big piece. Then we add them. Okay? So we're going to find the area of the big piece first. The area is going to be 15 times 4 of this big piece. We're going to separate them, cut them in two, find the area of this piece, and then find the area of this piece, then add them. That's the idea. When we're given irregular polygon, that's the idea. So the area of this big piece is going to be 4 centimeters times 15 centimeters, which is 60 centimeters square. And the area of this side is going to be 12 centimeters times 2 centimeters equal 24 centimeters square. So we have 60 centimeters square and 24 centimeters square. We add them and get 84 centimeters square. And that is the area of this irregular polygon. Alright, now the thinking begins. Any questions? Please let me know. I'm here to help. That's J2T. Stay tuned for more.